When determining the best approach for supplying power to a pavilion's lighting and receptacle circuits, several factors warrant careful consideration. These include voltage drop, cable size and cost, grounding, and accessibility for maintenance. Firstly, the distance between the existing panel and the pavilion is a critical aspect. Running a long subfeeder, such as 400 feet, to a remote panel can lead to a considerable voltage drop. This voltage drop can negatively impact the performance of lights and appliances, causing them to operate inefficiently or even malfunction. Secondly, mitigating voltage drop typically involves using larger size cables for the subfeeder. While larger cables effectively reduce voltage drop, they also increase material costs. Therefore, a balance must be struck between performance and budget. Thirdly, proper grounding is paramount when installing an outdoor panel. A reliable grounding system is essential for circuit protection and preventing electrical hazards. Improper grounding can create dangerous situations. Fourthly, maintenance and accessibility should be considered. A remote panel may be more difficult to access and maintain compared to one located closer to the pavilion. Ease of access can be important for routine inspections and repairs. Considering the previously mentioned factors, installing a small subpanel on one of the pavilion's columns is generally recommended. This approach offers several advantages. 1. Reduced voltage drop. By locating the subpanel closer to the point of use, the subfeeder length is significantly reduced. This results in less voltage drop and improved performance of connected equipment. 2. Lower material costs. Smaller sized cables can be used for the shorter subfeeder, leading to savings on materials. 3. Simplified grounding. Grounding the subpanel is typically easier and more reliable than grounding a remote panel located a considerable distance away. 4. Easier maintenance. The subpanel's proximity to the pavilion makes it more accessible for any necessary maintenance or repairs. Beyond the primary decision of panel location, several additional considerations are important for ensuring a safe and reliable electrical system for the pavilion. 1. Surge protection. Installing surge protection devices at both the main panel and the subpanel is highly recommended. Surge protection safeguards sensitive electronic equipment from damaging voltage spikes caused by lightning or other electrical disturbances. 2. Ground fault circuit interrupter or GFCI protection. All receptacles in the pavilion should have GFCI protection. GFCI receptacles are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock. 3. Adequate wire sizing. It is essential to ensure that the wires used for the subfeeder and branch circuits are properly sized to handle the expected electrical load. Proper wire sizing minimizes voltage drop and prevents overheating. 4. Physical protection. The subpanel should be enclosed in a weatherproof and tamper-resistant enclosure. This protects the panel from the elements, such as rain and snow, and prevents unauthorized access. When calculating voltage drop, several factors come into play. These include the length of the wire, the current flowing through the wire, and the wire's resistance. The formula for voltage drop is voltage drop equals current times resistance. The resistance of a wire depends on its material, length, and cross-sectional area. Copper wire has a lower resistance than aluminum wire, making it a more efficient conductor. The American wire gauge or AWG system is used to specify the size of electrical conductors. Smaller AWG numbers indicate larger wires with lower resistance. For example, a 12 AWG wire has a lower resistance than a 14 AWG wire. The National Electrical Code or NEC provides guidelines for wire sizing based on the expected load and voltage drop. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate the required wire size, you can use voltage drop calculators or consult NEC tables. These tools take into account the wire length, current, and allowable voltage drop to determine the appropriate wire size. For example, if you have a 20 amp circuit running 100 feet and you want to limit the voltage drop to 3% on a 120 volt system, you would need a 10 AWG copper wire. If you were using aluminum wire, you would need a larger size, such as 8 AWG, to achieve the same voltage drop. Grounding is a critical safety aspect of electrical installations. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and clear the fault. The grounding system consists of several components, including the grounding electrode conductor, the equipment grounding conductor, and the neutral conductor. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The equipment grounding conductor provides a path for fault current from electrical equipment back to the grounding system. The neutral conductor is the current-carrying conductor that returns current to the source. The NEC specifies the requirements for grounding electrical systems. These requirements vary depending on the type of system and the application. For example, a separately derived system, such as a generator or transformer, requires its own grounding electrode system. GFCI protection is required in many locations where there is a risk of electrical shock. These locations include bathrooms, kitchens, and outdoor areas. GFCI receptacles and circuit breakers are designed to detect ground faults and quickly interrupt the circuit. A ground fault occurs when current flows through an unintended path, such as through a person's body. GFCI devices trip when they detect a difference of 5 mA or more between the current flowing into and out of the device. Surge protection devices, or SPD, protect electrical equipment from voltage spikes. Voltage spikes can be caused by lightning, utility switching, or other electrical disturbances. SPD work by diverting excess voltage to ground, protecting connected equipment from damage. There are two main types of SPD, Type 1 and Type 2. Type 1 SPD are installed at the service entrance, while Type 2 SPD are installed at downstream panels. The NEC requires surge protection in certain applications, such as dwelling units and critical facilities. When selecting a subpanel, several factors should be considered. These include the number of circuits needed, the amperage rating, and the enclosure type. The subpanel should have enough spaces for all of the branch circuits that will be installed. The amperage rating should be sufficient to handle the expected load. The enclosure type should be appropriate for the environment in which the subpanel will be installed. For outdoor applications, a weatherproof enclosure is required. The subpanel should be installed in accordance with the NEC and local electrical codes. The subpanel should be securely mounted and properly grounded. The wiring should be neat and organized. All connections should be tight and secure. Regular inspection and maintenance of the electrical system are essential for ensuring safety and reliability. The electrical system should be inspected periodically for any signs of damage or deterioration. Any problems should be corrected promptly. The subpanel should be kept clean and free of debris. The circuit breakers should be tested periodically to ensure that they are functioning properly. By following these guidelines, you can ensure a safe and reliable electrical system for the Pavilion. The recommendation to install a subpanel on one of the columns considers the balance between minimizing voltage drop, managing costs, ensuring safety through proper grounding, and facilitating easier maintenance. This approach provides a practical and efficient solution for powering the Pavilion's electrical needs, while also adhering to safety standards and best practices. When sizing the subfeeder, it's crucial to consider not only the immediate load but also potential future expansion. However, sizing the subfeeder slightly can provide flexibility for adding more circuits or increasing the load on existing circuits in the future. This proactive approach can save time and money in the long run by avoiding the need to upgrade the subfeeder later on. The location of the subpanel on one of the columns should be carefully chosen to minimize the risk of damage from vehicles or other equipment. Consider installing bollards or other protective barriers around the column to prevent accidental impact. Additionally, the subpanel should be positioned at a height that is easily accessible for maintenance but also out of reach of children and animals. When running the subfeeder from the main panel to the subpanel, use appropriate conduit to protect the wires from physical damage and environmental factors. The type of conduit used should be suitable for the location and application. For example, Rigid metal conduit or PVC conduit may be used for underground installations, while electrical metallic tubing or EMT can be used for above-ground installations. Ensure that the conduit is properly supported and secured to prevent sagging or movement. When terminating the wires at the subpanel and main panel, use appropriate connectors and follow the manufacturer's instructions. Ensure that all connections are tight and secure to prevent overheating and electrical faults. Use a torque wrench to tighten the connections to the specified torque value. Label all circuits in the subpanel clearly and accurately. This will make it easier to identify and troubleshoot circuits in the future. Use a circuit directory card or label maker to create professional-looking labels. Keep the circuit directory up to date whenever circuits are added or changed. Before energizing the subpanel, thoroughly inspect all wiring and connections. Use a multimeter to verify that the voltage is correct and that there are no short circuits or ground faults. Test all GFCI receptacles and circuit breakers to ensure that they are functioning properly. Once the subpanel is energized, monitor the load on each circuit to ensure that it does not exceed the rated capacity of the circuit breaker or wire. Use an amp meter to measure the current flowing through each circuit. If any circuits are overloaded, redistribute the load or add additional circuits as needed. Regular maintenance of the electrical system is essential for ensuring safety and reliability. Schedule periodic inspections by a qualified electrician to identify and correct any potential problems. Check for loose connections, damaged wiring, and corroded components. Clean the subpanel and remove any debris or obstructions. Replace any worn or damaged parts promptly. Keep a record of all inspections and maintenance performed on the electrical system. This will help you track the performance of the system and identify any recurring problems. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation and maintenance of the subpanel. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. Always turn off the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable electrical codes and regulations. By following these guidelines, you can ensure that the subpanel is installed and maintained safely and reliably. This will provide a safe and reliable source of power for the pavilion for many years to come. When selecting wiring for the subfeeder, consider using copper conductors rather than aluminum conductors. Copper has a lower resistance than aluminum, which means that it can carry more current with less voltage drop. Copper is also more resistant to corrosion, which makes it a more durable choice for outdoor applications. However, copper is more expensive than aluminum, so you will need to weigh the cost against the performance benefits. When installing the grounding electrode for the subpanel, consider using a ground rod that is at least 8 feet long and driven into the ground vertically. The top of the ground rod should be buried at least 1 foot below the surface of the ground. Use a ground rod clamp to connect the grounding electrode conductor to the ground rod. Ensure that the connection is tight and secure. The grounding electrode conductor should be sized according to the NEC. When installing GFCI receptacles, be sure to test them regularly to ensure that they are functioning properly. Use a GFCI tester to simulate a ground fault and verify that the receptacle trips. If the receptacle does not trip, replace it immediately. GFCI receptacles should be installed in all wet locations such as bathrooms, kitchens, and outdoor areas. When installing surge protection devices, be sure to select devices that are rated for the voltage and current of the electrical system. The SPD should be installed as close as possible to the equipment that it is protecting. Follow the manufacturer's instructions for installation and maintenance. Surge protection devices should be inspected periodically to ensure that they are functioning properly. If the SPD has been damaged or has reached the end of its service life, replace it immediately. When selecting an enclosure for the subpanel, consider using an NEMA-3R enclosure. NEMA-3R enclosures are designed to protect against rain, sleet, and snow. The enclosure should be made of a durable material such as stainless steel or aluminum. The enclosure should have a hinged door with a latch to prevent unauthorized access. The enclosure should be properly grounded. When installing the subpanel, be sure to follow all applicable electrical codes and regulations. The NEC provides detailed requirements for the installation of electrical equipment. Consult the NEC and local electrical codes to ensure that the installation is safe and compliant. Obtain any necessary permits before beginning the installation. Hire a qualified electrician to perform the installation if you are not comfortable working with electricity. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. By following these guidelines, you can ensure that the subpanel is installed safely and reliably. This will provide a safe and reliable source of power for the pavilion for many years to come. Remember, electrical work should always be performed with safety as the top priority. If you are unsure about any aspect of the installation, consult with a qualified electrician.